Evening, fam. Let's just start with this question. So we are gonna answer this one, then go to the next question, the recursive sum question. So with this one, I wanna start first by explaining and recapping on lambda functions. Let's just do this full screen. Yeah. So what's a lambda function? Remember we say the lambda function is a nameless function. So what do? We usually assign it to a variable so that we can store it there, so that we can just reuse it from that variable, lambda. So our argument in this case is x. Let's use two arguments in this case just to recap. So you can just say every time we are gonna find square, it's gonna be two arguments x and y, and we're gonna say x to the power of y in this case. Then let's just call it power function. Calling it power function. So we haven't really started explaining our code, but I want us to recap on this first so that we can remember how lambda functions work. Then we can pass our two arguments in this case. So basically we have two arguments. The first argument is x, the second one is y. Then we say x to the power of y. In this case, it's 5 to the power of 2. So that's our lambda function. Hope you all remember that structure of a lambda function. Yeah? So this function that you see here, it's a sorted function. Basically, sorted functions is just to rearrange words. So if we pass words inside sorted without anything, it will just rearrange words. But the key argument, of the sorted function, what it does, it sort of adds more to that. Unlike just sorting, it sorts and adds extra parameters, other sorting functionalities. So in this case, what's added? We were told that the key tells us that the key is equals to lambda x, which simply tells us the sum of 1 for x in character. So in this case, x all the time will be the word apple, banana. Every time those words will be passed through the lambda function. So when x, let's say x in this case is apple, in this case it will run, then that's x. So we will iterate through what? Through apple. Then after iterating through apple, we are gonna filter what's inside of apple. I hope it makes sense, And what are we filtering? Basically, this is actually counting the number of vowels in each sorted case. So I want us to do this. Let's just run this lambda function independently. Then let's see what it does, and also run the sorted function. Let's see what it does. Then combine the two principles and see what the output will be. Yeah. So let's start off with lambda. As we started with lambda, let's just call it test lam. So it's basically our test lambda. So it's should have just copied and paste lambda of x. Then we are gonna find the sum 1 for car in x. If what's our if statement? Car dot lower in I O U. Is it fine? Yeah, I think it's fine. Let's just run it. It works. Let's just end this. So basically, I want to pass all of these arguments inside the function. So we are going to test for apple, banana, kiwi, and orange and see what it returns. Let's print. Let's use an F string for apple. Let's just do a colon apple. Then we use braces. What do we want? We want to call our test lam. And when we call it with apple as what? Apple as the argument. Let's close our F string, close our print, And let's just copy and paste this. Banana. Then this is what banana. Then what do we have? We have a kiwi, the third fruit, and the last fruit we have what? Orange. We haven't changed this just to make it neat. Kiwi, and we have orange. We have orange. So basically we want to test this function that's gonna be used to filter. We're just gonna test it with all the fruits independently. We just wanna see how it behaves. Let's just close that. And this one is irritating. Yeah, that's yes for this session. Yeah, it's off. Let's run the function. So what do we see? We see that apple is what? 2, banana is 3, kiwi is 2, orange is 3. So what does it mean? So when we are sorting using the sorted function, what will it do? It will definitely tell the key that we have 2 vowels in apple. We have 3 vowels in banana, 2 in kiwi, and 3. So how does the function work? So basically, let me rewrite this code, this for loop, as a normal for loop. So if that's the normal for loop, a normal for loop will be something like this. Let's say car in the same principle there that applies will be written in this way, car in x. So basically we assume that x will be any argument, any argument. Then we'll have an if statement. The if statement will be for car dot lower in a e I o u, our vowels. Then we would use some parameter, not x. I like x. Let's use y is equals to 1. So maybe initially we would say the value of y is equals to 0. So in this case, this is how this principle will work. Let's just take an example. Then say x in apple, in apple. This code apple is not defined. Oh, I forgot to put in these. Forgot to put in those. Let's run it. Oh, we must print what? We must print y. Let's print y after that. Yeah, y is 2. So you see the same principle applies. Yeah, the same principle applies. I'm just doing this so that you guys we can start also revising for the test. So another way you can write this, you can put it in a function called let's just say lam test, lam test in this case. Then you can just put an argument x in this case, and the same thing will happen. We just have to do this. Return y. If we run lam tests, then we just put x in this case. I forgot yeah. Yeah. Sorry for that. So let's recap again. So we have x, which is gonna be passed inside our function in this. Let's just call it test. Let's just call it test case. So that will be our test case. So basically what's happening, we are taking x here, we are taking apple, and we are going to pass it inside of what? Of this function. So this function is just a replica of what? Of our lambda function. So basically I wanted you guys to also remember we can convert normal functions to lambda functions. So basically this lambda function, in a normal instances, it will be implemented like this, But yeah, that's not what we are doing. Let's leave that. Let's go back on top. Let's leave that for now. So still on that case, let's see what sorted function does, I want us to sort of rearrange this. I want us to bring this one here so that you can see the use cases of sorted. And let's just copy and paste that. Let's just cut it. Let's just return it. Yeah. Let's just copy words. Let's put words there. Then we are just gonna put sorted. Let's just print. I want us to print sorted without doing anything, so that you can see what sorted does in this case. So basically, sorted rearranges the list in alphabetical order. So now sorted has been added a key that does what? Basically, all of this is the lambda function that we just explained and converted it to a normal function. That does what? It's simply counting the number of vowels in what? In the words. Ne? Basically, this has 2, this has banana has 3, kiwi has 2, oranges has 3. So that's the initial sorting principle. So basically, it will sort according to that. Basically, the ones that have the least number of fruits will be taken to the front. So in this case, what's expected from this code? Apples has 2, kiwi has 2. So those 2 will be printed first in the list. Basically, will be rearranged first in the list. So basically, this is what sorted returns. So for now, because this one doesn't have the key that's there, that you see there. So basically, kiwi, apple will be first. Why? Remember, we are going to sort first based on what? Which one has the most number of vowels. Then after that, we are going to sort based on which one has the alphabet that comes first. So basically, in this case, apple and kiwi has the same number of vowels. So they will come first after implementing what? This key sorting function. After that, we will have bananas and oranges because they both have 3. Then bananas has how many? Bananas has 3 vowels, oranges has 3. But bananas starts with a B, orange starts with an O. So basically that will be sorted first. So when we run our code, we'll see what I'm saying. Let's run the code. Oh, we forgot to print here. Let me print sorted words. Let's print. So you see these two has 2. So they're gonna start first. Then based on apples and kiwi, we consider which ones to print first. We will print what? We will print kiwi. We will print apples first because it starts with a A. Let's just show that. Let's make apple to start with a P, Z. It still starts with a. So I think it considers what? Basically, it considers the order. It doesn't consider the alphabet. But you can also test. Let's add A here to sort of increase the number of vowels in this one. So you see now this one has 4 vowels. If you would run banana written like that, you see now it has 4 vowels. What happens? The key function tells us that the one with the most number of vowels will be last, because what? The way it's sorting in ascending manner. So it will start with the ones that have 2, then it will come with the one that has 3, then it will come with the one that has 4. So basically that's how sorted is used in this case. Hope that makes sense. I know I went through a lot of things, but I just wanted to recall and for us to sort of also cover what we previously did in class, to sort of revise in the process, because this can be a typical question. You can be given a lambda function that's like this, then you're expected to convert it to what? To a normal function. So I hope that too also helps you remember what's required and what's expected from you guys. So if you are required to convert that lambda function, it will be something like this when it's a normal function. I know it's a mouthful and it's a lot of information to process, but you can just slow down the video and watch it again. Let's recap top down. So the question was just analyzing this function, the sorted function. So what sorted does, it rearranges. That's the main goal of sorted. But when you pass the key parameter inside of sorted, it will rearrange according to the key. And in this case, our key was telling us sort according to the one that has, the least to the most number of vowels in this case. So that was the key that was passed. I just wanted to break down the key so that you can see the different aspects of it. So every time, this statement is true, this statement is true, this if statement is true, basically the sum is going to keep track of that value that's allowing this statement to be true, and it's going to keep increasing. But besides that, otherwise, enjoy the rest of your evening.